Hello everyone. Today we shall see this experiment called load test on DC shunt motor. So the aim of this experiment is to determine the efficiency of DC shunt motor by conducting load test. Okay. So the apparatus required are voltmeter, ammeters, two ammeters, okay, one tachometers and connecting wires. See here, this is your circuit diagram. Okay, here you have, this is a 3-point starter and an ammeter, voltmeter is there. Okay, this is a field coil and this is an armature coil. To the armature, brake drum is connected. To the brake drum, S1 and S2 are connected. Okay, so this is your circuit diagram, and let us have a practical exposure of it. So you can see here. Okay, so here you can see that you have a starter is connected. Okay, DC supply is there here, and this is a starter. This is a starter, and you have 220 volts DC switch there. Okay, and this is a motor, that is, this is an armature coil and this is a field coil. Okay, you have one voltmeter, this is of 300 volts, and this is ammeter which is of 20 amperes, and this is ammeter which is of 2 amperes. Okay, so this ammeter, it is, you can see this ammeter is connected to the line. Okay, to the supply it is connected, and from the supply it is coming to the line L. Okay, you can see these terminals L, A and F. Okay, and you can even see the brake drum. Okay, this is the brake drum we have. And here are the motor specifications. Okay, so let us start this motor and take few readings. Only one reading will be taking, because the same procedure we adopt to determine the load. Okay, so here you can see in the tabular column you have voltage. Okay, IL, load current. Okay, speed N, S1 and S2. S1 and S2 you can see here. Here you can determine S1 and S2. Okay, by applying load to the brake drum. So that is by tightening this. Okay, by tightening this you can apply the load to the brake drum. So here you can see, so from this you can calculate the torque, output and input, and thereby you can calculate the efficiency. Okay, let us start the motor. See here, the moment it is on, it is 220 volts. See the starter, by applying the starter you can hear the sound. Okay, it is moving now. Okay, the motor is moving, you can hear the sound. So to make coolness to the brake drum, okay, water is added there. Okay, for cooling of the brake drum. So initial current you can see here, it is 2.1 ampere. Okay, and 1 point. So you can see the speed here. So in the tachometer it is showing 1464. Okay, 1466. You can see here N is 1466.
Voltage 220.
See here I am writing voltage 220 volts.
IL 2.4 amps.
IL 2.4 amps. You can see here. This is IL.
1466.
Okay, 1466 is RPM.
S1 S2 is 00.
S1 S2 is 00. Okay, you have not applied any load, so S1 S2 will be 0. Now we shall apply one load, only one load, single load. Okay, see here. So I am tightening the switches. So you can see here the load you can vary up to 5 amperes. Here the switch is connected.
19.5.
It is for 19.5 here. Okay, armature current you can load it for 19.5. Okay, see here, this is how you need to add the load. By tightening the switches you can see the belt position, it is changing. Okay, yes, it is changing here. See here you can see the current.
5.
I am tightening the switch now. Okay, it is enough. You can see here. Okay, S1 S2 you can see here, it is almost 1 and it is 7. Okay, and you can see the current. So current you can see here, it is of 5.5, and S1, S2, you can see here this one is S1 and S2. Okay, S1 is 1 kilo and S2 is 4. Okay, the speed is measured here by using tachometer, you can see this. So it is, the speed is 1410. Okay, so this is how you need to do this experiment, and you have the calculations here and all the formulas are written. Just substitute the values in the formula and calculate the efficiency. Okay, the after calculating the efficiency, write the result. Okay, so draw this graph. Okay, draw this graph.